Welcome back, everyone. And as you can see by the images, we're going to continue a little bit more with our particle systems. In the last video, we built up our particle system and we use TransformFeedback, a feature in WebGL that allows us to do all the movement calculations on the GPU side and update the state inside a buffer. So this way, every time we render, we compute it, save the state, and then we actually render the final the placement of each particle. In that example, we actually had to create pretty much a particle in the buffer, one vertice or one attribute each inside the buffer. And today we're going to deal with instancing. Now, when you're dealing with simple point particles, you don't need to use instancing. But if you're going to do meshes and things like that, like we actually want to have quads or cubes and spheres or any other odd multi-vertice shape or polygon or whatever you want to call it, when we need to do things like that, instancing is very important. So today we're going to experiment with instancing, and someone commented in the last video and they really wanted to see this, so I really kind of put something aside to get this working right. So hope you enjoy it. So we're going to do some optimization too while we're at it, since the first version is really just a big dirty prototype. So in our shader, I took out vLife from our feedback list because we're never updating life. The life of our particle is always static. If you want to make the life of your particle dynamic, then you put it back into feedback and then you update its value. But in the way I've been using it for the last video, I'm not. So it'd be kind of nice to show you like a blend between what isn't and what is, what's instance, what's static, what's dynamic. It's a nice big blend of everything in this one example. So that's one little change. I just moved it out of the way. If in case I want to bring it right back, I just drag it right over. As you can see, the numbering system changed. Originally it started at 0 at position. Now we're doing vertices. Vertice will actually contain our mesh data, basically. In this example, we're going to only store a single vertice in our mesh data instead of storing multiples. And so we have position, which is the position we're going to move. Then we have the velocity, how fast we're going to move at every frame. And basically this is like the starting age of a vertice or your particle, and this is how long your particle can live. So basically, if this started at time 10 and the life is 30 and you compare it to current time, you can say, well, current time minus age gives me like how much life do I have left in the particle. So we're still keeping life in there. We're still bringing life into it as an instance value, but it's not a transform feedback value anymore. So this is basically our regular vertice mesh data. These three are instance and they're also transform feedback data, and this one's only instance data. So like a nice little blend of everything else. Like I said, we're commenting out life because the out is for the transform feedback, but like I said, we're not updating it. Everything stays mostly the same. In our main function, like everything practically is the same. The velocity, age, whatever. We comment that life. Like I said, we're not updating it. And at this point, we have our A vertice, which is our attribute vertice that we're pressing, and this is our mesh. And we're going to add our V position to it. So that's kind of the big change, because now V position is really like world space where it needs. So A vertice is really our local space position, and V position is where we want to actually move it. And more examples I've done after this, I actually call this offset. It makes more sense, but for now we're calling this position. But in future videos, I'm going to rename this to offset. So this will be position, like since the beginning of the series. So all our vertices will be position, A position, and this will be offset. But for now, for this video, just so we don't the changes of the code from the previous example, I want to keep the changes minimum. So just keep in mind, this is our vertices for now, and this is basically our offset, how much movement we're doing. So when when we have brand new life, our position's at origin, and then as the particle life continues, it has some movement. So we calculate its velocity, and in this example, we're actually, setting up a random velocity when it's born, and then we're going to modify its velocity by applying gravity to it. So the particle starts moving up in some direction, and then gravity takes hold and starts bringing it down. Position, we're shrinking down our velocity and adding it to our offset, and we're saving that offset. And then age stays the same. Since it's a feedback transform, we still need to save it. If we don't save it, this will become like 0. So even though we're not changing it, we need to save it. That's why, even though I wasn't changing it, this had to be saved regardless, because else the value would be turned to 0 when this transform feedback completes. And everything else stays the same. I did find a new random function when I was looking at code. I haven't used it yet. It looks like it comes mostly from Microsoft, so it might be worth, if you guys want to play with it, a different random function. I have several random functions, noise functions, hash functions, kind of just throwing them at the end of this file so I can at some point remember to come back and play with it. So that's really our shader. We haven't done too much changes in our transform feedback to implement instancing. Everything is practically the same, and now we're going to do our changes in the emitter. Now, this should be familiar. We're creating an array of vertices, just like when we create a mesh. And for now, I'm setting it up below the ground grid, so it lives below the grid. So so our particle is gonna fly from below the ground and through the ground, basically. This is how we had it done before. In the previous video, these were basically our was essentially our vertice array, and that was all the attributes for the vertice. In this instance, or in this example, we're not hard coding the values. We're actually going to make a loop out of it. So ti is like just the instance, how much we're going to go, and ii is just a value for which actually I don't need anymore. So I actually started with creating the arrays, like recreating these arrays dynamically. But in the end, to optimize it, I really don't need those arrays. Those arrays are not needed because I'm going to initialize these values in the shader themselves. So for optimization tricks, like these two values, we don't need them. We don't need these values. Same here. We don't need to create those arrays and push them into our buffer. So the only things we need to really calculate for our instance is age and life. Age I set as negative 9,000, because the maximum life here is going to be no more than 6,000. 6,000 milliseconds, which equates to 6 seconds maximum life of a particle. Later videos, I will show you how to not hard code this. It will be based on life. But for now, I'm hard coding it to keep things simple. So the only thing we're going to create is age and life. We don't need to create velocity and position. So as you can see, most of the code is still the same. To make it an instance, so far we just had to create a new buffer for vertices. So everything is still the same. We're using a life to give our total particle count, which we kind of don't need to do that because I can just use ti as the particle count. But I left code, like I said, I'm just kind of copy and pasting, just quickly modifying some changes so we can get instancing working. So now we're going to create just like in the previous video, we had 2 VAOs. We're going to swap back and forth between VAOs. Those are our renderers. And we have our 2 feedbacks. This is basically the ability to write into our buffers, where the VAOs lets us read from our buffers, the transform lets us write. So this is read and that's write functionality. So we're gonna create all our main buffers for each VEO, and we got our vertices, position, velocity, age. So there we go. So like again, the first thing we do is bind our VEO, and we're still doing straight up WebGL. I'm not gonna abstract this out yet. For at least for the next 2 or 3 more videos, we're still gonna do things the hard, long way. So you guys kind of get used to seeing this again, because we've been abstracting a lot. So I want you, this way, anyone coming into here will actually can do this in OpenGL or in WebGL from scratch and everything else. So bear with me if you don't like seeing all this extra code, but at least you get to see it again, how building buffers, because we're going to be manipulating buffers quite a bit in to deal with particle simulation. So it's good to really see this, because we actually need to trickery and play with this a bit. So again, here we're creating our vertice buffer that we've always done for the last 50 some odd videos. So we push in our data, and it's a static draw. We enable it in the VEO, and then or basically this one defines the VEO, how to read that buffer, basically. In case you don't remember what this function, it just defines how to read it. It's how many components does it have? It's X, Y, Z. What type is it? Is it float? And then those values aren't really needed, because we're not grouping a bunch of data into one buffer. So sorry, and so that's our vertices. So that's what we've always been doing. Next, now we're going to start doing some our feedback data and instance data, because this position, velocity, and age are both. So in the previous video, we were passing in our array position, and I changed it to dynamic copy. Now it's instead of static copy, because that's the better mode to be in, since we're doing a lot of updating. So instead of passing our data into our buffer, like I said, I'm not creating that data anymore. What we're going to do is this next line of code is that we're going to initiate the buffer with the right amount of bytes needed to store all the data. So TI is how many instances we have. So if we have 10 instances, so it's 10 instances times 3 floats, and each float has 4 bytes. So we actually have to, like I said, we have to calculate how many bytes this buffer is going to take based on how many instances of vec3s that we have. So this creates a nice empty buffer that our feedback transfer shader can actually fill in on the first call. And like I said, this illustrates it, this enables it, and this creates this creates the instance. This one line is what turns this into an instance value. And this is basically the location, which is the same location we used for the last 3 values of where this value exists. So in position, it's position 1. So if you go here, in case you remember how this all works, here it is, location 1. So the next thing, and this kind of rinse and repeat for velocity. We again create an empty shader, an empty buffer, and 222. Age, we actually create that array, so we're actually going to push it in there. So we're going to push it in. It's defined at 3, but it's a single float. So the value changes from 3 to 1. It's a single float, and it's still an instance of 1. So it's 1. Like in this instance, I say 1, right? But that means 1 group of 3. So that means when the shader does the instancing, it knows that it has to do the groups by 3 when it does instance. So it grabs the first 3 and uses that for all the vertices. Then grabs the next 3 for the. So that's what that value is. Like how many of these are we looking for? I think there's other values to it, but for now that's what it really does. But you can do more with that. So we got age, we got life. In life, again, we just push in the data and we make it an instance value. Now it's an instance. And at the very end, we close out our buffer, and then we start setting up our transform feedback. Like this is all all this allows us to create the read functionality. This is buffer reading functionality. At this point, now we're setting up the feedback, the transform feedback. This is the write functionality. This gives us the, like in a previous video, I say like the portal, the pointer, a method of where we can actually access and write to a buffer. And as you can see, position equals 0, but position is actually 1. So I think in the previous video I said they have to match. They don't really have to match. It's if you're going to create a in the later videos, it makes it easier to make the match. But when you're doing everything, because when you're dealing with meshes, you can't do it this way. Meshes require a two-step process, and when you're dealing with two-step process, you can actually keep them together as the same location values. But since we're doing this in a one-step process, because points allows us to do that instead of making it a two-step, like 2 draw calls, the locations are actually different. So the input or the read position in the buffer is located in location 1 in this shader. But here it's location 0 because it's the first or the zero index of the out. So that out, these 3 things define our feedback transform. So that's why this position has a location of 1, whereas this has a location of 0, even though they're the same values, the same buffers, but they're 2 different variables inside the shader, and they exist in 2 different locations because based on the type of variables they are. So just keep that in mind, that you have to keep track of which is what, because like I said, one's for reading and one's for writing. And that's it. And then we keep track of which VO we're currently using. Everything else is almost the same. Now the only difference is before we were using draw arrays, now we're just going to do draw arrays instance. And we just pass in our vert count, which is just 1. And how many particles are we doing? We're actually doing, I think, 10, right? 10? Yeah, we're going to start off with 10 particles. And that's it. So if I save, and I come over here, and there goes our first particle, and then here comes the rest of the particles. The first particle is actually all 10 particles going together at the exact same time. We need to do like some kind of delay thing. I'll probably do that in later videos, but for now, this is now our particle system running 10 particles using a single mesh of a single vertex. Just refresh the full screen. And there you go. Now, since everything's set up as a loop, we can go in right here and say, well, let's make 1,000 particles. If I go back and refresh, that's 1,000 particles in one spot, and then there they go. And now we have boatloads of particles. Now let's do some more fun. So let's go back into our shader. Let's see, what changes can we do? Let's want to show you the difference between these two. Let's change its size based on its age again. So based on its age, it's going to get smaller. Refresh. Let that particle go. And I don't think it's getting smaller by age. Is it? No, it's not. Did I save this correctly? Save. Go back. Refresh. Yeah, now it's getting smaller. There you go. So now the particles are actually getting smaller the older they get. Like the closer they get to death or to the end of their lifespan, they shrink. So you got another effect going on. And you still got gravity affecting it. So let's get rid of gravity. Let's not apply gravity at all to this. Let's have this thing keep going straight up in the air. Actually, like yeah, nah. Because I'm trying to remember, because I've been playing around with effects with this particle system. All right, so is our particle system, nice and zeros, and it's nice and random. What are we up to? Let's do 10,000 particles. Let's see how bad this can get. Refresh. Get that one particle flying away. There you go. And that's 10,000 particles. Let's go for broke. 1, 2. Let's do 1,000,000 particles. It's probably going to churn. I haven't tried it on this computer yet. So going a little slower. I see a smaller frame rate. But overall, it's doing pretty good. 30 frames per second. Doesn't look like 1,000,000. But it's supposed to be 1,000,000. Refresh again. Now, let's do one more thing. Let's do this just 100,000. And click save. And now, we're setting up a random value using vertex ID from the previous video. Now, the thing is we're passing a single vertex. That means every single vertex has the same seed value of 0 because there's only one vertice that we're actually rendering. We're just rendering 10,000 copies of one vertice because we're doing instancing. If I want to apply the real value of the index, we have another GL value called GL index. So this will start at 0 and will, for every single particle, will actually have its own ID, which starts with 0 and goes up to like 10,000 because we have 10,000 particles. Now, if I change the seed value of the random per particle, we get a whole different effect. And now we got a wacky, amazing effect going on here. And you get to see it's kind of like a nice weird water going on because we got gravity on. Let's see. I actually haven't tried it without gravity, so let's see what happens when we apply no gravity whatsoever. Refresh. We start off with that. It makes basically kind of like a tornado. So now we had like a nice kind of a water effect. Now we got a tornado going on. Now when we kind of grade, if we take this effect, right, we have a nice tornado basically, and set it up where the renderable itself can move. So we can have this like move randomly. So this particle effect can be programmed to walk around the scene, and you basically kind of have like kind of a tornado thing going on. Anything else we can do with this? Sure, why not, instead of using squares, let's do the circle thing. I haven't seen how this works, but let's see. Refresh. Once we have like tons of particles, it's actually kind of hard to refresh the browser. Yeah. There you go. Okay. Probably able to tell the difference between tiny little squares. You can see the circles now. You can go flying into the... And at the same time, you kind of got to create kind of a nice tunnel effect, I guess. But yeah, you can play around with it. You can slow down, play around with the randomness. Yeah, that's what it looks like. Oh, that's cool, kind of neat, kind of interesting spiral effect. And from afar, it looks so much more different. Like instead of being zoomed in, so that looks pretty neat, especially with circles instead of squares. That's awesome. Now this is the stuff I really wanted to get into. Just making weird particle effects. This is more fun to do. And here we go. Like I said, everything is instant. It's a single vertice mesh that we're using. We're instancing it, and then we're using TransformFeedback to update its age, its position, its velocity, direction in which it's actually moving. That's essentially velocity, really. So yeah, and based on which angle you look at, it looks just pretty neat. Like I said down here. So yeah, that is the next second video about particle systems. The next one, we're going to now do mesh data. We're going to do quads. Quads are a very useful thing. And then we're going to do quads, and we're going to try to make it as simple as possible because it's a two-step process to do quads. We kind of have to rewrite all our emitter code because dealing with meshes is different than dealing with points. Because we can't render and compute in the same shader. So we have to create two different shaders, and we have to do two draw calls, one for computing and one for rendering. So that's, for the next video. And think about after that, maybe use particle systems, or use our particle system functionality to create maybe a bunch of grass in our grid floor, just randomly, that maybe sways back and forth to create some kind of wind factor. So that'd be maybe 2 videos from now. And that will also introduce, since we're doing quads, we need to introduce billboarding. And so that'll be a great example of billboarding and maybe how to skew a quad so we can make grass look like it's moving. And you got to find a nice texture to kind of load in. You got to fix up the loader to bring in textures. So yeah, so those are the next 2 videos. Is next is quads, and then doing some fun things with quads after that. With quads, we're probably gonna make something like smoke a little bit, just something simple, low poly, crappy looking smoke, but it's still a particle effect regardless. So that'll be in the next video. Then grass. Then after that, I have no clue. So yeah, I hope you're enjoying it. Like and subscribe. If you have any comments, any suggestions, or any things you really want to see, if there's any special effects you want to see, tell me. Send me some links or photos of what they look like, and I'll see if something I can kind of put together myself. Like I said, I'm doing this really quickly because someone asked for it. So I was actually going to go back to armatures, which I kind of did a little bit of it, but I decided to take a little bit of time away from armatures to do something for you guys, because apparently you guys want to do how to do instancing. So next, like I said, next video we'll do more instancing, but with meshes. So that'll probably be more exciting. I'm sure you guys can't wait till I start doing fields of grass. So again, like and subscribe. If you have any problems, ask away. See you guys at the next video.